With the tool of graphing, we can now proceed on into Chapter 4. So we're going to continue with 4.1, position, speed, and velocity. And today we are going to talk about speed. Your learning goals. Again, explain the meaning of motion. That's going to be a learning goal throughout each of these parts. And the second learning goal for this video is use the speed formula. So from all of our experiments and from our discussions that we've had, we know about position, we know about distance. Position is your place relative to an origin. Distance is how far between 2 points or 2 positions. And now that we've done the walk, jog, and run lab, you see that there is a relationship between as you move and as time passes, you can find a new variable. This variable is going to be speed. The variable speed describes how quickly something is moving. And all you need to know to figure out how fast an object is moving is how far did it go and how long did it take to travel that distance. So you'll notice the equation V equals d over t. Speed is the v, d is the distance, and t is the time. All lowercase letters. Make sure to jot down that equation. You don't have to write down the units next to the descriptions of each of those. You can just write v equals d over t, and I would highlight that for sure. Equations are going to be big ones that you're going to want to keep track of. I'll always give them to you on a quiz or a test whenever I ask you to solve a problem. But, so you can refer to them quickly as you flip through your notes, aside from just highlighting the blue words, definitely also highlight these equations. To show how the speed equation works, we're going to use this example. A student sprints 30 meters in 6 seconds. How fast is the student moving? In order to solve this problem, we have to break it down to figure out how to figure out the speed. So we start off with what are we looking for? And I'm using a problem-solving box that will assist me in doing this. So first thing I need to know is what am I looking for? Sorry about the glare. Well, if we look at the question, it says, how fast is the student moving? Fast. Speed. We want to know speed, which we can just write down, put it over here, v. All I got to write is v, just the variable that represents speed. What are we given? We're told that the student sprints 30 meters, which is distance, in 6 seconds, time. So, distance is given to us and it equals 30 meters. Time is given to us and it is 6 seconds. Awesome. What are now our relationships? What do we need to know? What is the equation? Speed equals distance over time. That is our clue that unlocks the secret to figure out what is speed. So, to solve, start by rewriting the relationship. V equals d over t. Speed equals distance over time. Now plug in with units. Equals 30 meters, because that's our distance, divided by 6 seconds. That's our time. Now you do the math. 30 divided by 6, that's going to be 5. So this equals 5. The units, because they don't cross out, are going to carry down. So m slash s become m slash s, meters per second. This student was moving 5 meters per second. And it should make sense because if the student went 30 meters and it took the student 6 seconds, the student was moving a distance of 5 meters for every second that passed by. In time was 0. He didn't move. By the time it reached 1 second, 5 meters. 2 seconds, 10 meters. 3, 15, 4, 20, 5, 25, and 6 seconds, 30 meters. So it makes sense. Every single second that ticks by, 5 meters of distance were traveled. That's why we say 5 meters per second. So a little more about units of speed. Units of speed are distance units over time units. And I'd like you to copy down the table that you see right there. First one is the one we just did. When the distance is in meters and the time is in seconds, we say the speed is meters per second. And we abbreviate that m slash s. If the distance is kilometers and the time is hours, it's kilometers per hour, km slash hr. The one some of you may be most familiar with is the bottom one. When distance is miles, time is hours, and we say miles per hour, or mph. We typically use that p only with the miles per hour. It represents per or divided by. When we're using the metric system, I strongly prefer, or I do prefer, only give me the slash. Please do not put MPS. While technically it is correct, this is the right or the better way to do it, the one that is used in science. Let me just box my answer, I can't forget that. So what we just calculated is something known as average speed. There's actually 2 types of speed. The first one is average. And when you divide the total distance of a trip by the time that it takes you to get from point A to point B, we call this the average speed, roughly over that time interval how fast you were going. Because if you think about it, look at the example on the right. The car is driving all which ways, left, right, up, down. And what we would do to figure out what that car's average speed is we have to know the total distance that car is going to go and how long it took it to go that far. So if you look just underneath the image, it says that the car traveled a total of 150 kilometers. And it took the car 1.5 hours to do that. So on average, during that time interval, the car was going about 100 kilometers per hour. We did the exact same thing in the walk, jog, run lab. Now, you guys attempted to maintain a steady pace, but, well, with the exception of the slow, fast, slow person. But it's entirely possible that you could have sped up or slowed down or shifted around. So you were able to figure out overall for the 30 meters that you moved your average speed during that distance and time interval. The other type of speed, so average is total distance divided by the total time it took. The other type of speed is instantaneous speed. And that is the actual speed an object has at any given moment. One of the best examples of this is if you look at a car's speedometer while it's moving. Next time you're in a car, glance over at that dashboard and see what the car is moving at. That's the car's instantaneous speed. But if you know while you're driving around, that speed is changing. You come to a stoplight and you stop. You go fast and you're going quicker, quicker, quicker. The accumulation of all of those instantaneous speeds, total distance over total time, that's your average. Instantaneous is exact point what isn't. So that's what we're going to go with on for speed for now. In an upcoming video, we're going to talk about something known as velocity, that last thing in 4.1. But we're going to work with speed in class, and I will see you then.